Yeah. All right, that's you now.
All right. So we started with our cart on the top of the hill, and then we let it go down. Started at the positive and went down toward the zero.
So when the cart started at the top, it was slow, and as it went down the ramp, it sped up and increased velocity as it went towards the origin.
All right. The slope of the graph is decreasing, and it's the slope's also negative.
All right, so the velocity time graph, it started slow, so it starts at 0, and then it gets more negative because the slope is negative because velocity is negative.
And then the acceleration is negative because the cart is speeding up, so which means the velocity is negative, so then the acceleration is automatically negative.
Okay, so that's a rule buster right there as far as our everyday thinking about things. Most of you, when you walk into this class, would have said, if I'm speeding up, I got a positive acceleration. If I'm slowing down, then that would mean I'm having a negative acceleration. But you just said speeding up is a negative acceleration for your example, right?
Yes, because it's starting at the positive and going towards the origin.
So it's starting out in somewhere in positive land and heading back towards 0 in the coordinate system, the origin. And so it's heading in the negative direction. You guys said something about the rule, if you speed up, your arrow points the same way you're going, or if you're slowing down, it points the other way, the acceleration one. So good job applying that rule to ignoring what might have been like a preconceived idea that if I speed up, it's positive acceleration, slow down, it's the opposite, because that is not a rule unless you only live in the positive world. And you guys are living in the negative world here. One question, did anybody's ears kind of perk up and go, oh, what? In the description of the curving downwards of the position time graph, would you point towards the curving downwards? Yeah, that one. What?
So it's curving down because, well, it starts flat, which means that it starts slow, and it increases in speed, but in the negative direction, so the slope increases.
So steeper slope always goes with faster speed.
Yes.
Okay, so it got steeper as it curved downward. And here's the other thing that students always tell me on the test. If I ask you to describe the motion of the car on the hill, if you're given that graph. So here's a graph, the meter stick is pointing at it. What might be going on for this thing in this world? And I do not want to hear you say, it starts high and goes down and gets steeper. That's what the graph is doing, but not what the real world object is doing, right? So please, please, please put it in your mind right now. If you're never just describing the shape of a graph or something. You're like, what does this tell me about a real world object and what it might be doing? So this could very well be a person on the top of a half pipe on a snowboard or a skateboard, and they'd be going downhill, but in quote unquote that world's negative direction. Don't associate downhill with the shape of that graph though. That person might be speeding up in the negative direction. So I just made the mistake I'm asking you guys not to do. You would say that person is speeding up while moving in the negative direction, and I know this because the graph's steepness is getting steeper, and therefore I understand that means the real world skateboarder is going faster. So you can use what the graph is telling you to justify what you want to answer in words about the real world object. So that's the confusion that happens all the time. So other than any little clarification about the graph got steeper, which wasn't a misstatement, it was just kind of the way it was worded. It made my red flag go up. Everybody like that graph, that description or set of graphs? Okay, we'll call that good so you can make sure you got it that way in your notebooks.